Okay, so for our second video for today, we're going to look at momentum. This is going to be our next subtopic for motion chapter. So for momentum, first of all, let's look at the concept of momentum. Okay, so momentum is the mass multiplied by velocity. Okay, this is the formula for momentum. In symbol, we can write momentum, small p is momentum equal to mass times velocity. Alright, so units. Okay, units for momentum, mass is in kg. So kg, velocity is meter per second -1, ms -1. So this is the unit for momentum. All right. Okay. Now for momentum, it's very simple. Objects which are moving has momentum. Objects which are stationary do not have momentum. Right. So velocity is important because if the velocity becomes 0, then the momentum will also be 0. Right. Therefore, we can conclude that if the mass is greater or if the velocity is higher, therefore the momentum of the object will increase. Similarly, if the mass of the object is smaller or the velocity of the object is lower, therefore the momentum will be smaller or decrease. Alright, so that is concept of momentum. Next, we're going to look at principle of conservation of momentum. Now, principle of conservation of momentum is a principle we have to remember. Now, first, let me give you the definition. Okay. So the principle says that in a collision or interaction between two or more objects, okay, in a collision or interaction between two or more objects, the total momentum before collision is equal to the total momentum after collision. Okay, so the main thing here, the whole idea of this principle of conservation of momentum, okay, this principle is that in a collision between two objects, okay, the total momentum before collision is actually equal to total momentum after collision, which means that the momentum is conserved. Conserved means it does not change before and after collision. Alright, let me give you an example. Well, let's say if we have two objects, okay, two objects, say this is 2 kg, okay, which is, I label it as M1. Okay, this is M1, and this is M2, which is 3 kg. Okay, now when these two objects, let's say M1 is moving forward with a velocity U1 equal to 4 meter per second. Okay, and let's say M2 is moving in the opposite direction, U2 equal to Okay, let's say it's moving at 5 meter per second. Okay, now these two objects are going to collide. Okay, they are moving in the opposite directions. I've given you the mass m1 and m2, 2 and 3 kg. U stands for initial velocity. Okay, u1 is initial velocity of the first object, u2 is the initial velocity of the second object. Now after collision, let's say these two objects collide. After collision, what happens? Okay, now after collision, right, let's say these objects will collide and this is m1 and this is m2. Okay, now let's say after collision the object m2 is moving in this direction but at a slower velocity because it collided, right? Let's say it's moving at 3 meter per second. Okay, now I want to calculate what is the final velocity of m1. That is my question, right? So this is the kind of question that you will get. So this m1 is same here, 2 kg, so here also 2 kg, this is 3 kg. All right, so let me show you how it's done. Now the whole concept is based on total momentum before the collision is equal to total momentum after collision. Okay, so let me write it down here. Total momentum before is equal to total momentum after. Okay, now the formula for momentum, earlier we looked at the formula for momentum is mv, mass times velocity. All right, so we are going to use that. We calculate, okay, we calculate the momentum of the first object. Okay, since it's mv, okay, I'm going to say m1 times u1. How do I get it? m1 and u1. Okay, this is the total momentum of the first object, right, before collision, plus, because total momentum, so I plus the second object momentum before collision is m2 u2. Okay, m2 u2 equal, right, so second object after collision is going to be still m1, but we don't know what is the v1. I'm just going to write as v1. Now remember, u is initial velocity, v is final velocity, plus, okay, plus this object is m2 v2. Okay, this is actually v2 because velocity of object 2 after collision. Okay, so now let's fill in into the formula. Now the mass 1 is 2, u1 is 4 over here, 4 plus m2 is 3, u2 is 5, okay, equal to, just substitute in accordingly. m1 again 2, v1 we don't know, we want to find, so 2, leave that as v1, we want to find, plus m2 is 3, v2 is 3, okay, 3 also. So here 2 times 4 is 8 plus 15 equal to 2v1 plus 9. Okay, let's solve that. Okay, so this is 23 equal to 2v1 plus 9, shift 9 over, so we get 2v1 equal to 23 minus 9, we get 14. Okay, then v1 will be 14 divided by 2, which is 7. because it's velocity meter per second. Now the sign here turned out to be positive, right? It's positive. If it's negative, when you calculate and shift, it will turn out negative. This positive means the object is moving forward. So 7 will be this one here. The V1 is actually 7. Okay, that's what we found. Right, 7 meters per second. The velocity of object 2 after collision. So we can use this formula. Okay, we can use this formula. Depending on the question, they may give you an unknown as maybe U1 is not given or U2 is not given. Okay, the others will be given, or maybe the mass is not given. Right, so based on what you are given, you will have to use the formula and calculate. All right. So that's about for momentum section. So I will upload some questions for these topics, these two topics. So please try out the questions, and you can ask me anything which you are doubtful. Okay, you can ask me on WhatsApp. All right. Okay, so we'll end here.